Hello, I'm Xiangrong. I'm a PhD student of the Hong Kong Polytechnic University. Today, I'm honored to give you a presentation about our recent study on a web-driven code mixing lexical resource, the Sina Mandarin alphabet words, shortened as CMOR. This project is collaborated with Wan Mingyu. She is a joint postdoctoral fellow of the Hong Kong Polytechnic University and Peking University. We are very pleased to investigate this task under the instruction of Professor Su Qi, Huang Juren, and Lu Qin. This presentation consists of 4 parts. I guess most of you may not be very familiar with Mandarin alphabet word, so I shall first briefly introduce the background and the research purpose. Due to the mixed use of Chinese character, English letter, pinyin system, and many symbolic tokens, identifying Mandarin alphabet word is far more complicated than ordinary new word discovery. In the second part, I will elaborately describe how we collected CMOR using a series of extraction and filtering methods. Next, based on the collected dataset, we have established a sort of detailed investigation. Evaluation results shall be demonstrated in this part. Lastly, I shall conclude our work with some future research directions. Mandarin alphabet word is an indispensable component of contemporary Chinese. It usually refers to code mixing words or lettered words. For example, Wei-Si is borrowed from English, and Doraemon is created for the famous Japanese animation character. Yet, this interesting phenomenon has not been properly addressed, and it is mostly excluded from the Chinese language system. Eventually, MAW can be dated back to the very early era of the last century. X-ray is the first MAW officially documented in 1903. Nowadays, the vocabulary of MAW grows rapidly in Chinese social media. Being an attribute of public creativity, a number of neologisms such as 坡主, post honor, and 后助, to endure, becomes widely used and accepted by Chinese society. One difficulty for MAW study is a serious lack of large-scale dataset. The number of existing MAW collection is very limited. The official Chinese dictionary includes only 239 MAW in the 2012 edition. Collected MAW in these dictionaries are very formal, but somehow outdated. It is inevitable that a dictionary can only collect the word with overwhelming domestic popularity. For example, BPG, beeper, and karaoke were very famous in the late 1980s and 1990s across China mainland. Huang provided a large-scale collection from Chinese gigaword corpus with more than 60,000 tokens in 2009. But the majority of their collection is pure alphabet words and even English words. For example, NBA, popular. Attribute to the homogeneous data source of Sinica corpus, Huang and Liu presented another MAW list in 2017. It includes 1,157 MAWs. There are a number of valid MAWs such as A 股, B 餐. To mitigate the serious data scarcity, we aim to further update MAW collection, especially from Chinese social media. Since language is developing all the time, a large-scale MAW collection can make it feasible to establish a wider scope of origin investigation for newborn words. MAW resources are also crucial for linguistic study such as morphology, phonology, and orthography. Additionally, Chinese sentence parsing can also be benefited from identifying MAWs, as these lexicons are commonly unrecognized by existing segmentation tools. For collecting a large-scale MAW list, we proposed an automatic system sourcing from Xinlang Weibo, the most famous social network platform. Collecting CMO is carried out through a two-stage process: candidate extraction and candidate filtering. In our system, candidate extraction uses an alphabet-anchored brute force extraction. By using this method, we can find MAW candidates from n-grams containing both alphabets and Chinese characters. Candidate filtering uses three methods to remove noisy candidates using 1. Rule-based refinement, 2. Informatics-based elimination, and 3. Search engine validation. Although rule-based refinement is simple and straightforward, it can greatly reduce the size of candidates. Based on our observation, 9 rules are proposed, which are either statistical metric, linguistic pattern, or syntactic information. Table 2 in our paper gives the noise reduction statistics. From this table, we obtain a set of 1,470,000 potential MAW candidates, which percentage is only 5.7 of the original set. Besides term frequency, point mutual information and entropy are also widely used in new word discovery. Appropriate limitation of PMI can ensure the internal cohesion. For example, A 股反弹 and A 股 are both frequently occur in our dataset, but PMI calculation indicates that A 股 is far more comprehensive. Similarly, 速 C and 维生素 C also have very high frequency, yet 速 C is not even a valid Chinese word. Entropy, in this case, can help us judge from the collocation possibility to find those candidates which can be used in more scenarios. Despite information-based elimination can further improve the reliability of remaining candidates, there are still some outliers. Let's take Li Yangyang as an example. Mrs. Li is indeed a KOL who has some influence in her domain. This candidate fulfills every previous criteria, but we humans can still easily recognize that it is not a MAW. It is just a combination of Chinese name and English nickname. To solve this problem, search engine can be served as an intellectual agent to provide some semantic information. First, we use MAW candidate as keyword to search via Baidu or other search engine. The top N links are first collected as external evidence. These links are then cleaned and passed to check whether this MAW candidate is meaningful. In our case, Li Yangyang occurs only as eta Li Yangyang Kelly. Thus, it will be identified as a username, not a real MAW. In addition to username checking, stickers and insufficient occurrency are also used as an indication of invalid MAWs. Other candidates which can pass search engine validation shall be regarded as valid. In the part of evaluation, experimental results are estimated by human raters. 3 groups of MAW are randomly sampled from each step of our method. Raters are asked to make judgment and give 1 if they think a candidate is truly a MAW, or 0 otherwise. Then, accuracy is calculated as the average of the 3 groups' acceptance rates. Incrementally, the candidate size is also studied for each filtering method. Inter-rater agreement among the 3 raters is also measured using kappa coefficient. Starting from brute force collection, Table 1 summarizes the cumulative performance of using various metrics for candidate selection. B0 is the baseline method that simply employs term frequency and the maximal sequence principle. In general, the accuracy increases when more filtering methods applies. Comparing with baseline method, our system makes use of more reliable extraction approach, which is obviously more effective for identifying alphabet words. The comparison of our web-driven dataset and the GigaList is also explored. It can be observed that most frequent MAW in the GigaList is 闭形, while in the web list, the most frequent one is hold住, which is a typical internet neology. Moreover, most MAW in Giga are disyllabic. For example, 假币 A 型, while CMO tend to contain words of wide range of syllables. For example, 哆啦 A 梦 玩乐攻略放. Especially, MAW in Giga shows a dominated pattern of X type, for example, H5 type, A type, B type. However, in WebList, MAW has more part-of-speech diversity. For example, verb, hold住, nouns, 避避双, or adjectives, 牛叉, which indicating that the trend of generating MAW accounting for different grammatical roles in the contemporary Chinese language. Lastly, the lexical sense of Giga MAW are more concentrated on the type or classification, while MAW in the web encode a wider range of meanings, including name, swear words, economy, entertainment, and etc. This figure shows the part-of-speech distribution of WebList and GigaList. We can easily identify that nouns are dominated for both datasets. The biggest difference between these two collections is adjective or modifiers is more used in Giga. And in general, the graph demonstrated that a more diverse lexical categories are used in web-driven collection. Okay, let me conclude our current progress. The work focused on using social media and the search engine to collect Mandarin alphabet words. The automatic collecting method we proposed achieves promising performance without involving manual mediation. We provided the MAW list and the corresponding corpus, which are most updated, scaled, structured, and comprehensive for supporting the following linguistic inquiries for this field. Our future work includes but not limited to, first, annotation of domains, source, active time, semantic class. Another direction is further linguistic analysis for uncovering the phonological, morphological characteristics. This is the end of our presentation. Thank you very much for your listening.